Welcome back to everyone. In this lecture, we will begin understanding how Verilog is used to structure, describe, and digital circuits. In the previous, we have learned about the various basic keywords related to Verilog. But here, we are going to learn about how to describe a digital circuit by using the Verilog code. So everything in Verilog starts with the name module, starts with the keyword module. So module is a keyword where we will start our writing a program. Suppose module, we are writing a program for AND gate. Then we will start defining the code with the module keyword, that is module and AND gate, or any name we can give. But for our proper identification of particular circuit, for the easier explanation, we will write a particular name by using the keyword module. So a module defines a hardware component or a system block. It's like the main building block of a circuit. Got it? Every program starts with a keyword module. So it lays the foundation of our starting the Verilog code. And it has three types of ports. One is input, output, and in-out. So what is the input signal which comes into a module is known as input. Output is a signal that go out of the module is the output. In-out is a bidirectional signal. So we can think of a module as a black box. From outside, you only care about the input and output. It has the internal logic which will help you do higher system design. So here, example I will show you. How to define module. Here you can understand. Module. Suppose you are writing a code for a AND gate. So we will start with the keyword module and underscore gate or AND gate, any name you can give. What I said, every Verilog code starts with the name keyword module followed by the particular programming. And there are three ports. How can we define the? It will have a input and output. In AND gate, how many inputs are there? Two inputs, one output. Suppose take an example. For AND gate, we have A input, B input, and Y output. So how can we define those? Input A, comma input B, comma output Y, followed by closing bracket and semicolon. Now, what is the logical for AND gate? A and B. So we can write assign Y equals to A and B. So when it's starting with a module name, it's always ends with a end module keyword. So it is a end module. This is a simple example for the how can we write the Verilog code for AND gate. So this defines an AND gate with two input and one output. Hope you got it. This is the keyword. These are the ports input and output. In AND gate we have two inputs, so input A, input B and output Y. Now we have to write the process of AND gate, that is assign Y equal to A and B and module. Hope you got it. In this slide, we will know the level of abstraction. So, every Verilog will support multiple level of abstraction, which allows flexibility depending upon our design goal. How we are going to design? We have three levels: gate level modeling, data flow modeling, and behavioral modeling. So, what is gate level modeling? It can define the logic gate using gates like AND or NOT or gate, XOR gate, ignore gate. If then gate level modeling is used when designing a standard cells or when a schematic is already available, then we can use the gate level modeling because if schematic is not available, if it is bigger circuit, then it is difficult to define which type of gate is used in a particular circuit. So whenever a bigger system is there and all the structural entities are already present, then you can use the gate level modeling to design the particular circuit. Now come the data flow. So data flow modeling will define how data flows using Boolean expression. You can even use the assign statement with logical operators for data flow modeling. So when you are using a combination logic, suppose AND gate, what is the two tables? A equal to A0, B0, 0, 1, 1, 0, 1, 1. So when you know the two table in hand, we can use the data flow. And what is the behavior model? It is a highest abstraction level where we write the logic as an algorithm by using always or initial block details we will learn about the behavior model. It is normally used for sequential logic design like designing of counters, finite state machine like Milley and Murray and control logic. This level also we can combine and write all the three levels at one place. But it is important to know where we have to use which level. Now this is the data flow model. So in data flow model, we will focus on the logical relationship between the input and output. We can use the keyword assign to create a continuous statement in data flow model. Suppose in any code we have use of word assign, then that particular we can identify as a data flow. It means the output updates immediately when the input changes. It is used for designing a combination logic. You can use the logical operators like AND for and the stage line for or escape symbol you can see for XOR gate and negation for not. Suppose we are I can suppose we are giving example 2 is to 1 multiplexer using data flow. So we can write example, we can write assign keyword is using the data flow. Suppose we are writing for 2 is to 1 multiplexer. So assign y equal to select line function operator either B or A signal. Okay. Now go for gate level modeling. Gate level modeling, as I said, when you have the schematic for bigger circuit, you can use this type of circuit like AND gate, OR gate, NAND gate, XNOR gate, or etc. Suppose we write for AND gate. For example, I will write for AND gate. So how can we define here? And because we are using for AND gate. Okay. While the output is B. Okay. While the output and the other signals, or else we can write also y equal to a and b. No need to write the keyword assign. Hope you got it. Now we go for behavior modeling. So behavior modeling will describe how the system behaves over time rather than its structure, and always we are using the always block for repetitive logic and initial block for simultaneous setups. Example, suppose we write D flip-flop with reset. So how can we write here? This is also one example using behavior modeling using D flip-flop. So Okay, the sequence module, data will write the effect, input output is a lesson, input, just example, this will write. And how can we write for the procedure? Always at the rate of, here we are using sequences, so always we have to use the clock. So always clock or always reset. You can see when it starts with begin, if reset, if reset, okay, if reset, you assignment, this is not less than equal to this, 2 equal to 1 thickness, 3, 0, 8, 2, spaces, and end. And then it is started with the module name, then and module. Hope you understood this. Let's have a look over the code. Positive flow cohesive, that means at the positive edge of clock or positive edge of the reset. If reset signal is activated, then output is equal to 0. If or else means if reset is 0, that means clock is 1, then output is assigned as the input D, which is the logic of D system. Now we'll go to the next slide. What are blocking and non-blocking assignments? This is one of the most critical concept in Verilog simulation. Blocking means it will execute line by line like as of C programming. When C program you are using, every line will execute line by line. Similarly, in blocking also in Verilog, it will execute line by line and using combinational logic. Then coming to non-blocking assignment, this will execute in parallel and also using the sequential logic. What do you mean by control statement? This is a control flow in behavior modeling is a standard programming construct like if else statement or so it is these are the code example 1 bit comparator you can write using an behavior data flow structural 2:4 decoder or D6. More examples you can learn. Okay, if any doubt you can ask me. Thank you.